Hello everyone, this is Dr. Srinivas, faculty in mathematics. Today we are going to discuss about the second unit, higher order ordinary differential equation of ODEVC, ordinary differential equations at vector calculus for BTech first year, second semester under JNTUH Hyderabad and its affiliated colleges. The important and most expected problems from second unit in the semester examination. The first one, find the general solution of y double dash plus y dash minus 2y equal to 0. Remember, whenever you are calculating the general solution for higher order, you need to calculate two types of solutions, yc and yp, complementary function and particular integral. So right side is equal to 0 indicates that you are calculating only yc. So better you calculate complementary function for the first problem. Second, find the particular integral of d square plus 4d plus 13 of y equal to 2 e power minus x. After getting yc, the yp can be calculated by applying the procedure of e power ax. 2 is a constant you are taking to the left. In e power ax, d is replaced by a. If denominator is equal to 0, directly you can use a procedure x to the power of k by k factorial, and if it is not equal to 0, directly you will get yp answer. Third one, solve d square plus 1 of y equal to sin x sin 2x. So after getting yp, so in order to make this simplification, sin A sin B type, sin A sin B can be calculated by applying the principles of cos of A plus B and cos of A minus B. So after adding or subtracting, you are going to get one principle in terms of cos. So apply the procedure of cos AX and you will get yp. Fourth one, d square plus 4 of y equal to tan 2x by the method of variation of parameters. So in the method of variation of parameter, after getting yc, yp is nothing but au plus bv. So a and b you calculate it and directly you can make the simplification to get your final answer. Fifth one, find the general solution of d power 4 minus 1 of y equal to 0. Since the right side is 0, you are calculating only yc. Sixth one, compute the particular integral of d power 4 plus 8d square plus 16 of y equal to 5. So while finding yp, the right side only 5 constant term is there. So additionally you can introduce e power 0x. So 5 you can take to the left and e power 0x you apply the procedure for e power ax. Seventh one, find the particular solution of d square y by dx square plus 3 dy by dx plus 2y equal to x e power x. So after getting yc, that right side it is looking like either it is x into v or e power ax into v. In any of the cases you will get your yp. So in the case of e power ax into v, you are taking e power ax to the left so that d is replaced by d plus a, and directly the remaining right side is only x. So there you can use your x to the power of k procedure. Subject to the conditions are given. These subject to the conditions are applicable only to find out arbitrary constants. Y of 0 equal to 0 means at x equal to 0, y value is 0, and y dash of 0 equal to 0 means at x equal to 0, dy by dx equal to 0. After getting the complete solution, you use these two conditions to get arbitrary constants C1 and C2. Eighth one, use the method of variation of parameters to solve a problem is given. So directly you can apply your variation of parameters. Ninth one, compute the general solution of, here also directly you can calculate yc. And 10th one, find particular integral of one differential equation, and right side is looking like it is e power ax. 11th one, obtain the solution of one particular equation is given, right side 8x square e power 2x into sin 2x, 8 constant, no problem. So from the right side only you are taking e power 2x to the left, d is replaced by d plus a, and the remaining right side is x square sin 2x. It is looking like x to the power of k into v. Apply the procedure and find out the answer. conditions are given only to find out the arbitrary constants. 12th one, use method of variation of parameters to solve. It's a direct problem and you can use it. 13th one, you are solving y double dash minus 3y dash plus 2y equal to x e power 3x and plus sin 2x. yp splitted into two subparts, x e power 3x for one and sin 2x for another. For the first part, e power ax into v type, take e power ax to the left, and for the v, the remaining part x is there, you can use x to the power of k procedure. And sin 2x, the second one is there, it is sin ax procedure. There d square is replaced by minus a square, and you are getting, if denominator is 0, directly you will get an answer. If it is not equal to 0, you are applying the rationalization process. 14th one, y double dash minus 4y equal to x cos hx, hyperbolic function is there. Cos hx can be taken as e power x plus e power minus x divided by 2. So I am making the simplification, it is looking like e power ax into v, yp is splitted into two subparts, and directly you can find out the answer. 15th, solve by variation of parameters, d square minus 1 of y equal to cos x. It's a direct problem. So these are the few important and expected problems from the second unit of ODEVC, higher order ordinary differential equation. So better you focus on such type of problems, maximum you can score in the final semester examination. So this is Dr. Srinivas, Mathematics. Have a good day and be practice well, and you will get a maximum score. Thank you.